Hello, and today's purpose of the day is I can factor monomials and find the greatest common factor. Let's take a look at a preview of Chapter 8, Section 8.1. Let's go ahead and read the Y section on page 471, Monomials and Factoring. Susie is making beaded bracelets for extra money. She has 60 gemstone beads and 15 glass beads. She wants each bracelet to have only one type of bead and all of the bracelets to have the same number of beads. Susie needs to determine the greatest common factor of 60 and 15. So let's take a look at a few of the questions that follow this. Question 1 says, what is a prime number? Do you know what a prime number is? Yes, it is any integer or number whose factors are 1 in itself, and this also has to be greater than 1. So let's go ahead and add that in. So again, we said any integer whose factors are 1 and itself, and also must be greater than 1. Okay, so there's the definition for what's a prime number. Question 2, what is the prime factorization of 60 and of 15? So let's take a look here at 60. So we're going to do what you've done before, maybe in past grades, and let's make a factor tree. So if I write 60, I now need to break down 60. So what goes into 60? And think of the largest perfect square. So 15 and 4. And then the square root of 4 breaks down into 2 and 2. And 15 breaks down into 5 and 3. So now if I write out the prime factorization of 60, that is 2 times 2 times 3 times 5. Now I'll also need to break down 15, and 15 only breaks down into 5 and 3, so the prime factorization of 15 is 3 and 5. So the prime factorization again of 60 was that first one, and the prime factorization of 15 was the second one, 3 times 5. So again, by making a factor tree, it's a little bit easier to go ahead and answer those questions. And I better lock these in place so they don't move. Question 3 now says, what are the common prime factors of 60 and 15? Well, if we write them out again, just so we can see them, 60 was 2 times 2 times 3 times 5, and 15 was 3 times 5. So what do the two have in common? Well, they both share a 3 and they both share a 5, and 3 times 5 is 15. So the common prime factors of 60 are 3 and 5, which is 15. So I could write 3 and 5 are the common prime factors. Question 4 says, what is the GCF of 60 and 15? So the GCF now, here, 3 times 5 would be 15. So 15 is the GCF, and I probably shouldn't have circled it up at number 3, because the common prime factors are 3 and 5 of 60 and 15, but the GCF, the greatest common factor of what goes into both of those, is 15. So then question 5 says, if we wrap all this up, how many and what kind of bracelets can Susie make? So let's go ahead and let's write out what we have here. So she has 60 gemstone beads. So she has 60 gemstone beads. And she also has 15 glass beads. Okay, so she wants each, if we read above again, she wants each bracelet to have only one type of bead and all the bracelets to have the same number of beads in them. So we know with 60, when we said the GCF of 1615 was 15, so she's going to be able to put 15 gemstone beads. And my stylus there, sometimes it's difficult to connect the letters to write because it needs a new top to it. So 15 gemstone beads, and then she can make 4 bracelets, right, that each have 15 total beads on them, so that will give her 60 total beads. So then she'll use all of those beads. And again, the bracelets have all the same number of beads, 15, and then she'll make 4 of them. So over here with the glass beads, she only has 15 glass beads, so she wants to put all 15 together. So I'll write 16 glass beads. And then how many bracelets will she be able to make? Well, here, so times 1 bracelet, she'll only be able to make 1. And that's just because she only has 15 beads, because 15 times 1 is 15 beads. So that brings us to some new vocabulary of 8.1, monomials and factoring. So a couple new words are factored form, and this is a monomial expressed as the product of prime numbers and variables. So that's factored form, and we just used a factor tree on the last slide, so we'll be using that a bit today, or in this video notes, so that we can completely factor monomials. And the greatest common factor is the greatest monomial that is a factor of both original monomials. So I'm sure you've probably heard that word before, and greatest common factor, shorthand of writing that would be GCF. So go ahead and take some time to write down those definitions. Now let's go through a few examples of factoring completely. So on number 1, I see 18x squared y cubed. So I'm going to break down 18 with a factor tree. And 18 breaks down into, and I'm going to think of perfect squares that go into 18. So I know 6 and 3 go into 18, but 9 and 2 would be better because 9 is a perfect square, which means I can take the square root of it. And so that just will help me when I want to completely factor. I know that that will be down to its lowest form. So if I break this up into 9 and 2, and 9 breaks up into 3 and 3, I know that that can't go any, whoa, I can't write a 3 there. That will be in its factored form. So this will be 2 times 3 times 3. Then with my variables, I have x squared, which breaks down into x times x. And then I have y to the third, which breaks down in just into y times y times y. So I really just have to write them all out. So here, let me erase this so I can move it over a little bit. So here, if I write out the completely factored form of 18x squared y cubed, I get 2 times 3 times 3 times x times 3y's. And again, I have to expand it all out because that's the completely factored form. All right, number 2 says negative 38 r p to the second t to the second. So I'm just going to break down 38, and then I'll just attach a negative 1 into my final answer. And so 38 breaks down into 2 and 19. And then 2 and 19 can't break down anymore. So I have negative 1 times 2 times 19 times r times p times t times t. And that would be the completely factored form. All right, let's look at one more. Number 3, negative 52a to the 4th b cubed. So again, I'll put the negative 1 there at the beginning, but I'll break down 52. And 52 breaks down into, 4 and 13. So if you think about it, 52 cards in a deck, there's 4 different suits and 13 of each suit. So to remember 52. And 4 breaks down into 2 and 2. So this would be 2 times 13 times 4 A's and 3 B's. Ooh, and I can't forget the negative 1. Again, it's always good maybe to write that down right away so you don't forget to put that in your answer. So now let's take what we just did on the last slide with finding the completely factored form, and let's find the GCF of 2 pairs of monomials. So what we'll need to do is when we look at the 2 pairs of monomials, we'll see, okay, what's the completely factored form of each, compare what they have in common, and pick out a GCF. So let's take a look here at number 1. 27a squared b and 15ab squared c. So I'm going to go ahead and break down 27, and 27 breaks down into 9 and 3, and 9 breaks down into 3 and 3. So 27 a squared b breaks down into 3 times 3 times 3, it's actually 3 threes, times A times A times B. And then 15 breaks down into, or 15A, can't write with this stylus anymore, B squared C turns into 3 times 5, so that one's pretty simple. A times B times B times C. So what do the two both have in common? Well, they both share a 3, they both share an A, and they both share a B. So together, what those multiply to be, the GCF then would be 3AB would be the GCF between those two monomials. Let's take a look here at number 2. So 8x squared y to the 5th and 32xy cubed. So 8x squared y to the 5th, 8 breaks down into 2, let's change colors here, 2 times 2 times 2, x, and then 5 y's. And then 32xy cubed. Well, 32, if we don't know what that breaks down into, let's write it off to the side. Would be 16 and 2, and 16 breaks down into 4 and 4, which then breaks down into 2 and 2, and 2 and 2. So this one would be 5 2's, x, and then 3 y's. So then what the two have in common would be 3 2's, an x, and then 3 y's. So if I multiply 2 times 2 times 2, I get 8x, and then y cubed would be the GCF. All right, last one here. 30q to the 3rd r squared t, and as we get better at these, we can start to do some in our head. 30 breaks down into what? 2 times 3 times 5 times 3 q's, 2 r's, and a t. And 50 breaks down into 25 and 2, and then 25 breaks down into 5 and 5. So 2 times 5 times 5, and then q, r, t. And what the two have in common would be a 2 and a 5 and 2 q's, an r, and a t. So this would be 10q squared, let's fix that squared, r, t. And that would be the GCF there of number 3. Thanks for listening. Have a great day. Bye-bye.